Hello, my name is José Miguel Contreras.
Hello, my name is Sebastián Díaz. We are students from the San Vicente de Paul Institute in San Gil, Santander, Colombia. And we are going to explain our tech project.
The technology project. This project is made up of the 12 motors, 18 legs, 2 H-bridge, a breadboard, Arduino, and 3 potentiometers. The potentiometers control different functions of the model. One varies the model in the model. One varies the intensity of the LEDs. Another is used to control the models. And another is used the map around each room. The project has a very complex concept, that my parent will explain below.
First of all, we're going to show that the model actually works. For example, there is the LEDs turn on and turn off in different rooms, as you can see, and the motors turn on in each room. And here is the code. Well, this is the code for the model my friend explained before, and I'm going to explain it part by part. First of all, we have the constants. These are where each element is connected. For example, PS, which is a potentiometer, is connected to A5. PL, which is another potentiometer, is connected to A3, and the other potentiometer is connected to A3. And the same with LEDs and motors. Then we have the setup. In this we set a mode for each element. For example, the potentiometers are input because they send signals to the Arduino, and the LEDs and the motors are output because the data elements need to receive signals for the Arduino. And finally have the loop, the most important part of the code. The first in the loop is initial values, which is everything off, set everything off for security. And then we have the variables, which is the value of every potentiometer in each loop. Then we have the ranges for S. S is a value that depends on the value of the potentiometer that controls classrooms. And if, for example, if BPS, the value of the potentiometer, is between 0 and 117, S is equal to 1, which then we, when other part of the code control every classroom in depending of which S is equal to. And the same from S equal to 3, 4, 5 and 6 depending on which range. Then we have a map with scale the analog entry to 0 between 1023 to output of between 0 and 255th. BL is the intensity of the LEDs. And we initiate the principal part of the code, which is two options. Use a lot of ifs to control every case, or you switch in a few cases, which is a very easy way to read the code and program it. In case 0, when s is equal to 0, turn all off. In case 1, when in cases 1 to 6, yes, 1 to 6 are all the same code. The only change is which LED and motor are controlling. In case 1 is LED 1 and motor 1, in case 2 is LED 2 and motor 2, and so on. Have a first part of that case is if the intensity of the LED is greater than 10, turn the LED on with a specific intensity that depends on the value of the potentiometer. Analog write is an analog signal. That means that it can be any. It has a very spectrum, a very range of values. Instead, digital write only can be 0 or 1. Analog, no. Analog is a range. And if that's not right, turn the LED off. Then another switch with depend of BPM, the value of the potentiometer who controls motors. Case 0 activates when BPM is lower than 512, I think. When it's lower than that, turn the motor off. And when it's greater than 5012, it turns the motor on. And this is a little bit of, it's a solve for an issue that before this, if you have the LEDs off and you turn on the motors, the LEDs turn on with the motors. Well, these two lines solve that issue. And case 2 to 6 are the same, only change the LED and the motor is working. And that's all. Goodbye. If you want to prove the code and the model for yourself, you can find the link for the Think a Car project in the description.